Have you ever wondered how your digital world seems to know you so well? It's machine learning, ML, quietly working behind the scenes. It's an invisible revolution reshaping our daily lives, making technology smarter and more personal. This technology learns from vast data, recognizing complex patterns. We're entering the age of generative AI, where machines create new things. Generative AI is transforming creativity, opening up new possibilities. This signifies a fundamental shift in how we solve problems. For those eager to build the future, there's never been a more exciting time. The journey starts with understanding these tools. Machine learning and generative AI are creating incredible career opportunities for passionate learners from diverse backgrounds. This guide is your roadmap from beginner to builder, creating intelligent applications. We will break down this complex world into manageable steps, providing a clear learning path. Starting with machine learning fundamentals, we will leap into generative AI and large language models. Move from user to creator, focusing on practical skills employers seek. Build a portfolio showcasing your abilities, proving you can solve real-world problems. Your career in machine learning and generative AI starts now. Machine learning teaches computers to learn from experience, much like humans. We give computers access to data and a general goal, and the machine learns to recognize patterns. Think about identifying a cat. Shown pictures of cats, your brain learned the general cattiness. This allows computers to perform tasks impossible to program explicitly. Machine learning analyzes data like emails, learning characteristics to identify spam. The fuel is data, the experience for the machine. The model is the machine's accumulated knowledge. It applies learned patterns to new data for predictions. It's automated learning and intelligent adaptation, a practical tool for solving complex problems. The most common type of machine learning is supervised learning. Imagine a student with a teacher. The teacher gives you flashcards with animal pictures and names. You study these to associate the correct name with each picture. Then, you identify new animals. This is supervised learning. A bank uses it to predict loan defaults. It powers many applications you use daily, like house price estimates or email sorting. It's excellent for prediction and classification when you have known answers. Now, let's explore the second major flavor of machine learning, unsupervised learning. If supervised learning is like learning with a teacher, unsupervised learning is like being given a huge box of mixed-up puzzle pieces with no picture on the box to guide you. There are no labels, no correct answers, and no supervisor. The goal is simply to look at all the pieces, the data, and find some kind of structure or interesting patterns within it on your own. You might start grouping pieces by color, by shape, or by the texture of their edges. You are discovering the inherent structure of the data without any prior knowledge of what that structure should be. This approach is incredibly useful when you do not have labeled data, which is often the case in the real world. Labeling data can be expensive and time-consuming. Unsupervised learning allows us to extract valuable insights from large, unlabeled datasets. The most common task in this area is called clustering. This is the process of automatically grouping similar data points together. For example, a marketing company could take its entire customer database and use a clustering algorithm to segment customers into different groups based on their purchasing behavior, browsing history, and demographics. This creates natural customer personas without needing to define them in advance. Another powerful application of unsupervised learning is anomaly detection. This involves identifying data points that are rare and significantly different from the majority of the data. Think of it as finding the odd one out. Banks and credit card companies use this technique to detect fraudulent transactions. The model learns what a normal pattern of spending looks like for a particular customer. When a transaction occurs that dramatically deviates from this normal pattern, like a small purchase in New York followed 2 minutes later by a large purchase in Tokyo, the system flags it as a potential anomaly or fraud because it does not fit into any normal cluster of that customer's behavior. Unsupervised learning is fundamentally about exploration and discovery. It helps us understand our data on a deeper level. Beyond clustering and anomaly detection, it is also used for dimensionality reduction, a technique for simplifying complex data sets by finding the most important features. This can help improve the performance of other machine learning models. While it may not provide the direct predictive power of supervised methods, unsupervised learning is a critical tool for data scientists. It helps make sense of messy, unlabeled data, revealing hidden structures and relationships that can drive strategic decisions and unlock new avenues for analysis. The third major category of machine learning is perhaps the most dynamic and intuitive reinforcement learning. This type of learning is modeled directly on how humans and animals learn from interacting with their environment. Imagine teaching a dog a new trick. You do not show it a labeled dataset of good and bad tricks. Instead, the dog tries an action. If the action is what you wanted, you give it a reward, like a treat. If it does something else, it gets no reward. Over time, through a process of trial and error, the dog learns which sequence of actions will maximize its chances of getting a treat. Reinforcement learning works in precisely the same way. In this paradigm, we have an agent, which is our AI model. This agent exists within an environment, like a game world or a simulation of a real-world scenario. The agent can take certain actions within this environment. After each action, the agent receives two things from the environment: an updated state, basically what the environment looks like now, and a reward or penalty. The reward is a numerical signal that tells the agent how well it is doing. The agent's sole objective is to learn a strategy or policy that chooses actions in a way that maximizes its total cumulative reward over time. It is a continuous loop of action, feedback, and adaptation. Reinforcement learning truly shines in situations that involve sequential decision-making, where a series of actions leads to a final outcome. The most famous examples come from the world of gaming. Google's DeepMind used reinforcement learning to create AlphaGo, the AI that famously defeated the world's best Go players. The agent played millions of games against itself, slowly learning the incredibly complex strategies of Go through pure trial and error, eventually discovering moves that human experts had never even considered. This same approach is used to train AI to master complex video games, often surpassing the best human players. Beyond games, reinforcement learning has enormous potential for solving real-world problems. It is being used to optimize the cooling systems in massive data centers, saving huge amounts of energy by learning the best fan and cooling unit settings in response to changing temperatures. In robotics, it allows a robot to learn how to walk or grasp objects through simulation before applying that knowledge to a physical body. It is also the driving force behind self-driving car policies that decide when to accelerate, brake, or change lanes to navigate traffic safely and efficiently. It is the key to building autonomous systems that can learn and adapt to dynamic, complex environments. To begin your journey into machine learning, you must first choose your primary tool, and in the world of data science, that choice is overwhelmingly clear: Python. This programming language has become the universal standard, the lingua franca spoken by ML practitioners, researchers, and engineers across the globe. Its popularity is not an accident. Python is renowned for its simple, clean syntax that reads almost like plain English. This makes it incredibly easy for beginners to learn, allowing you to focus on understanding machine learning concepts, rather than getting bogged down in complex programming rules. You can write powerful code with fewer lines, accelerating the path from idea to execution. The true power of Python for machine learning, however, lies in its vast and mature ecosystem. Over the years, a global community of developers has built an incredible collection of open-source libraries specifically designed for data analysis, numerical computation, and machine learning. These libraries are collections of pre-written code that handle the heavy lifting for you. This means you do not have to reinvent the wheel by programming complex mathematical operations or machine learning algorithms from scratch. Instead, you can import these powerful tools with a single line of code and immediately start applying them to your data, standing on the shoulders of giants. This rich ecosystem fosters a collaborative and supportive environment. If you encounter a problem, it is almost certain that someone else has faced it before and a solution is available online. Platforms like Stack Overflow, forums, and countless blogs are filled with Python code examples and expert advice related to machine learning. This accessibility removes many of the barriers that new learners might face, creating a smoother learning curve. You are not just learning a language, you are joining a massive, active community that is constantly pushing the boundaries of what is possible and sharing its knowledge freely, which is an invaluable resource for anyone starting out. Furthermore, Python's versatility extends beyond just machine learning. It is a general-purpose language used for web development, automation, scientific computing, and much more. This means that the time you invest in learning Python is a valuable asset for your entire tech career, not just for ML. It provides a solid foundation that opens doors to many different roles and industries. For all these reasons, its simplicity, its powerful libraries, its strong community support, and its versatility, Making Python your first language to master is the most strategic and effective first step you can take on your roadmap to becoming a machine learning expert. Your essential toolkit: NumPy, Pandas, and Scikit-learn. Once you are comfortable with the basics of Python, it is time to assemble your essential machine learning toolkit. NumPy is the fundamental package for scientific computing in Python. Next is Pandas, the ultimate tool for working with structured, table-like data. Scikit-learn offers a simple, clean, and consistent interface to a vast range of machine learning algorithms. Together, these three libraries form a powerful and cohesive system. Mastering this trio provides you with the fundamental capabilities required to handle end-to-end machine learning projects. Your first project: building a price predictor. Theory is important, but the key to truly understanding machine learning is to get your hands dirty with a real project. The best way to start is by tackling a classic beginner problem: predicting house prices. This is a supervised learning task, specifically a regression problem, where the goal is to predict a continuous numerical value, like the price. This type of project is ideal because it is easy to understand, the data is readily available, and it perfectly illustrates the fundamental workflow of almost any machine learning project. Your goal is not to build the world's most accurate model on your first try, but to learn the process from start to finish. The first step in any project is data collection. You can find many excellent data sets for house price prediction on platforms like Kaggle, a popular website for data science competitions and data sets. These data sets typically contain a spreadsheet-like file where each row represents a house and each column represents a feature of that house. Features might include the number of bedrooms, the square footage, the year it was built, and the neighborhood. The final column will be your target variable, the price at which the house was sold. This labeled data is the fuel for your supervised learning model. Once you have the data, you will move into the pre-processing phase using the Pandas library. Real-world data is almost never perfect. You will likely need to handle missing values, for instance, by filling them in with the average value for that feature. You might also need to convert non-numerical features like the neighborhood name into a numerical format that the machine learning model can understand. This cleaning and preparation step is critical. It ensures that your model receives high-quality data, which directly impacts its ability to learn effectively and make accurate predictions. This is where you will spend a significant amount of your time. Finally, with your data cleaned and prepared, you will use Scikit-learn to build and train your model. You will split your data into a training set, which the model learns from, and a testing set, which is used to evaluate its performance on unseen data. You can start with a simple algorithm like linear regression. You will fit the model to the training data and then use it to make predictions on the test data. By comparing the model's predictions to the actual house prices in the test set, you can measure its accuracy. Completing this simple project will teach you the core ML workflow and give you the confidence to tackle more complex challenges. The creative revolution. What is generative AI? Generative AI learns data patterns so deeply that it can create entirely new original content. This creative capability unlocks a whole new universe of possibilities. It is the technology behind the powerful tools that can compose original music, write articles, and generate photorealistic images. Once it has this deep internal representation, it can then sample from this learned knowledge to generate something new. This ability to generate new data has far-reaching implications across countless industries. This is the exciting new landscape you are preparing to enter. The explosive progress in generative AI is largely thanks to a revolutionary breakthrough: the transformer architecture. Introduced in a 2017 research paper, this model fundamentally changed how machines process sequential data. The key innovation is a mechanism called attention, allowing the model to weigh the importance of different words. This was a monumental leap forward for natural language understanding. Understanding the transformer architecture is essential. It's the engine that powers the generative revolution. With the powerful transformer architecture as the blueprint, the next logical step was to scale it up. This is where large language models, or LLMs, enter the picture. An LLM is, at its core, a massive transformer-based neural network that has been trained on an unimaginably vast quantity of text and code, encompassing a huge portion of the public internet. The sheer scale of this training data is what gives these models their incredible capabilities. By processing this immense library of human knowledge, LLMs develop a deep and nuanced understanding of language, grammar, facts, reasoning abilities, and even programming languages. The stunning emergent abilities we see in models like GPT-4 or Claude 3 are a byproduct of this massive scale training process on diverse data. These models contain billions, or even hundreds of billions of parameters. This immense size is what allows them to perform a wide variety of tasks without needing to be specifically trained for each one. A single, general-purpose LLM can be used for text summarization, translation, question answering, creative writing, and code generation, often with remarkable proficiency. Knowing how to effectively use large language models is key. The skill of crafting the perfect input to get the desired output is known as prompt engineering. The quality of the output is highly dependent on the quality of the prompt. It involves experimenting with different phrasing, providing clear examples. Sometimes you need the model to become a specialist in a particular domain. This is where fine-tuning comes in. Fine-tuning is the process of taking a massive general-purpose LLM and continuing its training on a smaller, specific, and high-quality dataset. These are the two primary methods for customizing and controlling the behavior of LLMs. Skillfully shape and direct them to solve real-world business problems. You have mastered the basics of machine learning with Python and its essential libraries. Now it's time to venture into the advanced territory that powers today's most sophisticated AI. Your next major milestone is to dive deep into the world of deep learning. Deep learning is a subfield of machine learning that uses neural networks with many layers, hence the term deep. These networks are inspired by the structure of the human brain and are exceptionally good at finding intricate patterns in large complex datasets like images, sounds, and text. Understanding concepts like neural networks, activation functions, and backpropagation is the next logical step in your educational journey. It's the bridge between traditional ML and the generative models you aim to master. To get started with deep learning, you'll need to learn a new set of tools. Libraries like TensorFlow, developed by Google, and PyTorch, developed by Facebook's AI Research Lab, are the industry standards for building and training deep neural networks. You should aim to become proficient in at least one of them. Begin by building simple neural networks for tasks you are already familiar with, like image classification or the house price prediction project. This will help you understand how these frameworks operate and how they differ from Scikit-learn. Deep learning is computationally intensive, so you'll also learn about the importance of GPUs for accelerating the training process of these complex models. Once you are comfortable with the fundamentals of deep learning, your focus should shift squarely to the transformer architecture. As we discussed, this is the engine behind modern generative AI. You need to move beyond a surface-level understanding. Study the original attention is all you need paper. Work through tutorials that break down its components, such as multi-head self-attention, positional encodings, and the encoder-decoder structure. You don't need to memorize every mathematical formula, but you should be able to explain how information flows through the model and why the attention mechanism is so powerful. This knowledge is a key differentiator for generative AI roles. The final stage of your advanced learning path involves practical application. This is where you connect theory to practice by mastering prompt engineering and fine-tuning. These are the skills that allow you to harness the power of pre-trained large language models. Start by experimenting with different prompting techniques using publicly available APIs for models like GPT or Claude. Then, find a small, specialized dataset and learn the workflow for fine-tuning an open-source LLM. Completing this entire path, from deep learning fundamentals to hands-on LLM customization, equips you with the complete, end-to-end skill set required to build the next generation of AI applications. Your resume lists skills, but your portfolio proves them. In AI, a strong portfolio is essential. It's your personal showcase of technical abilities and problem-solving skills. Quality over quantity is key. Each project should tell a story, detailing the problem, your solution, and the technologies used. Host your portfolio on GitHub with a clean profile and a README file explaining each project. Consider writing blog posts to showcase your communication skills and deeper engagement. Share these posts to increase your visibility in the AI community. Your portfolio should target the roles you want. Build projects that go beyond basics, like a house price predictor with advanced feature engineering or an image classifier using deep learning. For generative AI, include at least one LLM project. Fine-tune a chatbot or create a text summarizer web app. Solve a real problem you care about. Maybe a recipe generator or a tool that mimics your favorite author's style. Deploy your models as web apps using Flask or Streamlit to show end-to-end skills. Present projects with clear GitHub READMEs, visuals, and, if possible, a live demo link. Make it easy for recruiters to see what you built and why it matters. A focused, well-presented portfolio is your ticket to interviews. Once your portfolio gets you in the door, the interview process tests you on 3 pillars: behavioral, technical, and system design. Behavioral interviews assess your teamwork, communication, and problem solving. Use the STAR method and real stories from your projects. Technical interviews dive into your coding and ML Gen AI knowledge. Expect live coding, theory questions, and model trade-offs. System design interviews challenge you to architect AI systems, clarify requirements, and justify your choices. Excelling in all 3 areas is crucial. Prepare for each pillar to show you're a well-rounded candidate. That's how you stand out. Technical interviews test your depth, not just definitions. Be ready to explain bias variance trade-off, overfitting, and evaluation metrics like precision and recall. For Gen AI, expect questions on transformers, self-attention, and differences between models like BERT and GPT. Know how to fine-tune LLMs and discuss prompt engineering techniques. You may need to code simple ML tasks in Python. Practice clean, efficient code and explain your thought process. Show you understand both the theory and the practice. That's what interviewers want to see. Be ready to think out loud. Technical skills get you noticed, but behavioral and system design interviews set you apart. Prepare 3 STAR stories from your projects to answer questions about challenges, teamwork, and learning. For system design, start by clarifying the problem, break it into components, and discuss trade-offs: accuracy versus latency, complexity versus speed. Talk through your reasoning and engage the interviewer as a collaborator. Structure, communication, and practical thinking are key. Show you're not just a coder, but a thoughtful engineer. That's what makes you memorable. Make every answer count. A great AI career is built on passion and continuous learning. Stay current, read research papers, join online communities, and participate in Kaggle competitions. Don't just consume, create, write tutorials, contribute to open source, or build tools others can use. Even small contributions matter and show initiative. Follow AI leaders, subscribe to newsletters, and listen to expert podcasts. In interviews, discuss recent papers or projects you've explored. Show your curiosity and commitment to lifelong learning. That's what sets you apart in AI. You've seen the roadmap, a clear path to a rewarding career in technology. You've learned to build a portfolio and navigate interviews. Now take the first step. It's a challenging journey, with moments of frustration. Persistence and incremental progress are key. Focus, build, and celebrate small wins. Don't wait. The field is moving fast. Begin today. Your journey begins with a single line of code. Action is the greatest teacher. Go build the future now. We have journeyed together through machine learning and generative AI, from foundational principles to cutting-edge innovation. This guide has equipped you with a comprehensive strategy for building a compelling portfolio. The entire blueprint is now yours to embrace a future where you are a creator of technology. Continuous learning is your most valuable asset in the dynamic world of AI. Build the intelligent tools that will drive the next wave of innovation. You must be the one to walk the path. The future is built, code by code, model by model. Your journey into the heart of the AI revolution starts now.